Okay, so in this video, I want to actually prove where do these derivatives come from? The derivative of arc sine. Like, how in the world would we come up with this idea of the derivative of arc sine is equal to 1 over the square root of 1 minus x squared? And arc cosine is off by its negative. Arc tangent doesn't have a square root, but all of a sudden has x squared plus 1. Arc cotangent is off by its negative. And so I'm going to prove the first two, but really you could prove all 6 of them in a very similar manner. And you don't have to reproduce this ever. I'm never going to test you on this. But at the same time, I want to show you where does this come from, and I want you to be able to kind of analyze this and think about this. Just because it's good to see, like, how is that related? How is the definition of the derivative of arc sine equal to that particular value? So let's go ahead and remind ourselves, what is this actually saying? Remember, when I say arc sine of a ratio is equal to this angle, y is an angle in this case. And we're used to seeing that as theta, but y is referring to an angle. I have some angle y whose sine ratio is x, or in this case, x to 1. And so I can then think about, well, if this is side length 1 and this is side length x, is sine ratio sine of y is x over 1. I could also think about sine of y is equal to x over 1, or sine of y equals x. This and this are equivalent statements. It's just an inverse of it, if you will. Okay, let's go ahead and think about, well, I know how to take the derivative of this. The derivative of sine of y is cosine of y. But I'm going to multiply immediately by dy dx, because I'm trying to find the derivative of y with respect to x, and the derivative of x is 1. Now I can divide cosine y over, so I get dy dx is equal to 1 over cosine of y, which I should recognize as the reciprocal of cosine y, which is secant of y. So now I have dy dx is equal to secant of y. Now remember, y is an angle. Y is this angle right here. Secant of that angle would be the adjacent piece divided by the hypotenuse. Now I don't know this adjacent piece, at least not directly, but I do know it fits the Pythagorean theorem. So if I want to find this particular length, I could say 1 squared minus x squared square rooted will in fact give me that distance. Oops, too big. Let's make that a little bit thinner. Excuse me. So that could be 1 squared minus x squared. And now I hope you see where we're going to get these squares from. It's all the Pythagorean theorem, right? Secant of y is adjacent over hypotenuse. Therefore, how about hypotenuse over adjacent? Therefore, I'm getting 1 over the square root of 1 minus x squared. And I know I said probably that incorrectly throughout the video. Secant is hypotenuse over adjacent. Cosine would be the adjacent over hypotenuse. But there it is. There's our derivative, because remember, what is dy dx? We're trying to find the derivative of y, dy dx of arc sine, which is equal to 1 over the square root of 1 over the square root of 1 minus x squared. Okay, tangent. Hopefully I won't get too tongue-tied here. If you think about what this means, y equals arc tangent. Y is some angle whose tangent ratio is x to 1. So draw a picture. Red here. So here's angle y, here's the ratio x to 1, and if you want, we can go ahead and fill in the Pythagorean theorem already. This is the square root of 1 squared plus x squared. So already, I'm understanding why does arctangent have a sum where arc sine had a difference, just based on what was the unknown and what were you looking for in your triangle. Now, another way to phrase this, if y is the angle whose tangent is a ratio of x to 1, I can also say tangent of y is equal to x. Those are equivalents. And I can take the derivative of tangent, secant squared of y dy dx is equal to 1. And then again, secant squared of y, I can divide that over, so I would get dy dx is equal to 1 over secant squared of y, Or if I realize that that's a reciprocal of just cosine, so dy dx is equal to cosine squared of y, and now try not to mess this up, cosine of y would be adjacent over hypotenuse, squared. Doesn't affect the 1, but now we see where that square root goes away when I'm squaring it because of the fact that they undo each other. So dy dx is equal to 1 over the square root of 1 plus x squared as a quantity squared, which is our definition that we have below. There's our derivative of arctangent. So like I said, I'm not going to ask you to ever reproduce that, but I want you to have an understanding of where do these come from and why do they have square roots. And to be honest with you, it's because it's based on the Pythagorean theorem. Here they are. Here are the 6. And I know I mentioned this right at the beginning, but please look at that. All of these are negatives, right? All the co's are negative. They are all negative of their cofunctions counterparts. Okay, that's going to help you learn them, memorize them, commit them to memory. You have to know them. You have to be able to know them because as soon as you start taking derivatives of arc sine, I might throw in, well, let me rephrase that. I will throw in chain rule, and it might be part of a product or a quotient. So you have to know these derivatives, and you have to know them very, very well. Excuse me.